Let us see what a sample space is. It is a set of all possible outcomes of a random experiment. And what is a random experiment? A random experiment is any process where you know the possible outcomes. So in a random experiment, we know the possible outcomes, but we cannot predict the exact outcomes beforehand. For example, if we roll a die, we know the set of possible outcomes of a die. We can get a 1, 2, 3, 4, 5, or a 6. So this is a set of possible outcomes when we roll a die. But when we roll a die, we're not sure which one of these we'll get. So this type of experiment is called a random experiment. And the set of all possible outcomes of such an experiment. This is the set of all possible outcomes of the experiment where we roll a die. The set of all possible outcomes is called a sample space, and it is denoted by the letter S. So in case of rolling a die, this is our sample space. And if we toss a coin, we'll either get a heads or a tail. That means this is the set of all possible outcomes of the experiment where we toss a coin. And if we toss two coins, that means for an instance of the experiment, we are tossing two coins. So when we are tossing two coins, we'll either get a head for the first coin or a tail for the second coin, or a tail for the first coin or head for the second coin, or heads for both coins or tails for both coins. So in this experiment where we toss two coins, this is our sample space. Now let's define an event. An event is any subset of outcomes from the sample space. Mathematically, we can write it like this. So if A is an event and S is a sample space, then A is a subset of the sample space. When we roll a die, we can write the set of possible outcomes as. So this is our sample space when we roll a die. So what is an event? An event is any subset of the sample space. Here, any subset of this set is an event. We can define an event here like this. Event E getting even numbers. So what do I mean by this? For example, if we roll a die and if the outcome is an even number, we can say that event E has happened, because event E is defined as getting even numbers as a result of rolling a die. So we'll get event E will happen when we'll get a 2 or a 4 or a 6. So we can write event E as 2, 4, 6. As you can see, this set is a subset of the sample space. So this satisfies the definition: an event is any subset of outcomes from the sample space. Or we can define an event like getting a 6. So whenever we roll a die, if the outcome is 6, then we say that event has happened. And similarly, in case of tossing coins, we can write event F as getting a heads. So whenever we toss a coin, if we get a heads as a result, then we can say event F has happened. And in the experiment where we toss two coins, our sample space looks like this. We can define an event G like getting at least one heads. So if we get TH or HT as an outcome of this experiment, then we can say that event G has happened. Because if we get a TH, that means it contains at least one H. And if we get HT as the result, means it contains at least one heads. So event G can be written like this as well. Now let's talk about the frequentist definition of probability. Frequentist definition of probability is one of the most important interpretations of probability. It defines probability based on long-run frequency of occurrence. If we repeat an experiment many times under identical conditions, for example, let's say we toss a coin and we observe it. Let's say we toss it 10 times initially, 10 tosses, and after observing, we get 7 heads and 3 tails. And if we calculate the frequency of heads, that'll be equal to 7 over 10, which is equal to 0.7. That means after tossing the coin 10 times, the frequency of getting heads is 0.7. Now that doesn't mean the probability of getting a heads is 0.7. It is just a short run observation. Now if we repeat the experiment 1000 times, that means, and we get 503 heads and 497 tails, then the frequency of getting heads will be equal to 503 over 1000. That'll be equal to 0.503. And similarly, if we repeat the experiment a million times, we may get something like 0.4998 as the frequency of getting heads. So frequentists say that probability of getting a heads equals 0.5. Why? Because in the long run, heads appears about half the time. When we toss the coin 10 times, we got the frequency as 0.7, but that doesn't mean the probability of getting heads is 0.7. Now, when we repeated the experiment many times, the frequency of getting heads gets closer to 0.5. That is why we say that probability of getting heads is equal to 0.5 in the long run. Similarly, if we roll a die, let's say 6,000 times, and after observing, this is the sample space of the experiment. If we roll a die, that means we'll get either 1, 2, 3, 4, 5, or 6. And let's say the frequency of occurrence of each number is like this, 992. Now, if we want to calculate the probability of rolling 4, that is this row, we'll calculate it like this, and that will be equal to 0.166. That's closer to 1/6. That is why we say probability of rolling a number, if we roll a die, is equal to 1/6. Now formally we can write it like this. Probability of an event is equal to limit n tends to infinity. That means if we repeat the experiment a large number of times, limit n tends to infinity, number of times the event occurs divided by the number of times the experiment was repeated. So this is the formal definition of the probability, or the frequentist definition of probability.